Okay, the rotate instructions, very similar to the shift operations. So in shift operations, one end, either the right or the left, has bits shifted off, and the other end is either zero filled or sign extended if it's an arithmetic shift to the right. However, in rotate, the bits shifted off one end are used to fill in the vacant space at the other end. So this is where you say, gosh, you know, we had EAX, and we could use EAX, or I could get to AX, or I could get to AH or AL, but what about that? Why can't I get to that? Well, you can now. I'll show you how. This one, you could either do a shift to the right or the left by 16 bits, and that would move this to AX and AX to the high order bit. Okay, so let's look at the instructions, see how they work. Okay, all right, these are rotates right and left. They look very similar to the shift instructions. So destination for all of these can be byte word or double word in register or memory. And as each bit falls off, it is copied to the other end of the destination. The last bit copied to the other end is also copied to the carry flag. The overflow is the only other bit in E flags to be affected, and it's still going to be undefined for multi-bit rotates. So, only carry flag and overflow flag are the only flags, okay? Same rule applies for our 8-bit immediate values, either as an immediate value or stored in CL. If they are larger than, well, they'll be reduced by modulo 32. So the only valid range in effect will be 0 to 31 bits shifted in a 32-bit architecture. Okay? So there you have it. Let's, I've got just a couple of programs left. But let me do an example. Let's see if I've got some room here for an example. So yeah, let's say I want to do a rotate, and it doesn't matter where we do it. This one has a little more room. Let's say I want to do rotate to the right EAX by 97. Okay, so in this case, first thing off is my immediate value. While it is an 8-bit immediate value, will not work very well for me because it's going to be reduced by modulo 32. So when I do that, I'm going to get an effective mask of 1. So this is going to be a single bit shift or a single bit rotate to the right of EAX. And let's make this a little bit easier, and let's just say AX. So in this case, let's say AX before is AEF1. Okay, so AEF1. This is going to rotate to the right by 1 bit AX. So this 1 bit is going to rotate to the right, which means it's going to go right here. And my result will be D778. The carry flag will be 1. Overflow flag. So it was negative. It is still negative. It is a single bit rotate. So overflow flag is defined, and there was no sign change. Okay? All right. Sorry for the short video, but this is good. I wanted to do one example. We'll do these last 2 programs plus some other things in class.